Yes class, good morning. Today topic your problem solving exercise 1.2. Today's second lecture of this exercise. Name of this topic is types of the functions. Today I am taking question number 3rd. This is a different type questions in this exercise. Now look the question here. Prove that the greatest function R tend to R means domain and codomain both are real numbers, and fx equal to greatest function x is neither 1 1 nor on 2 when this denoted by greatest integer less than or equal to x. This is the symbol of the greatest integer function. This symbol is your greatest integer function. This symbol here greatest integer function. First, before solving the question, I will discuss some about the greatest integer function. Means suppose any function given, suppose here writing is the 2.5. The 2.5 means 2.5, which is the greatest integer here. 0.5 is less, the 2 is greater. The what value of this? 2. Suppose here write 2.1. What value of this? This is the 2. Means 2.9. This is the 2. Same things here. Suppose you write 10.1. What value of this? 10. Suppose you write 12.7. What value of this? 12. What is the greatest integer in both? That before decimal is greatest integer. Then you write here the average. Suppose 2.1 to 2.9. Then every value will be here 2 come. So this is the rules of the greatest integer function. So in this condition, when domain and codomain are real numbers, so in this condition we will check here if this function is 1 1 or on 2 is possible or not. Yes, now start the solution here. Yes, solution. Function here given. What function here given? Function here given f domain real number is defined by fx equal greatest integer function x. According to property of greatest integer function, first we will check 411 means, so when suppose you are putting value of the x here 1.1, that means f 1.1, what value here come here? 1. Same things here, what value? 1.2. What value here come here? 1.2. The result here come this 1.1 and this will equal to 1. Same here 1.2. Result here 1. It means here not required negative order. Only all positive number come the same. Means the image of the 1.1, image of the 1.1 is 1. Image of 1.2 here 1. So similarly, x equal we are putting 1.3, then function 1.3. This greatest integer function 1.3. Result also come here. So f 1.1 equal to 1.2 equal 1.3 equal 1. It means every element here 1.1, 1.2, 1.3, 1.4, 1.5, 1.9 till 1.9. Every element having the image is 1. So you can say hence you can say the f is not 1 1. Hence you can say f is not 1 1. Means this function is not 1 1. The half part you have solved. Half part you have solved. F is not 1 1 because every elements of the domain not having the unique image in the codomain. So this is the 1.1 having the image 1, 1.2 having the also 1, 1.3 having the image also is 1. It means this is not the 1 1 functions. The next second things here 4 on 2. 4 on 2. 4 on 2. What will be your fx equal to greatest integer function x, where x and y belong is the R. Means domain x y belongs R means domain, x and y. So this is the x and y. X is domain, y is the codomain. So both having the real number. Domain and codomain both having the real number here given condition. According x and y given the real number. So what value of the fx is y. This is the value of given function. Now look here. So this is the y equal to function of the x. Suppose you are domain having the every element. Suppose onto means the every elements of the codomain having the unique pre-image in the domain. This is the onto. Onto means every elements of the codomain. Every elements of the codomain having the unique image in the. This is the suppose this is the x. This is the y. This is the domain x and this is the codomain y. So suppose here every elements of the codomain. Suppose you have 1, 2, 3. But suppose you have 1.1, 2.1, 3.1. 1 is the having the image here. 1.1, 1.2, 1.3 and 1.5. So this is having the image. One having the image in the domain. When it means one having the unique pre-image in the domain, but 1.1 is not having the pre-image in the domain, because x and y both having the part of the domain codomain real numbers. But then so y, suppose you have 0.5 is belongs to y. 0.5 also is belong here. 0.5 is also belong here. Suppose example 0.5 having the element of this codomain, because y is the real number. Y is the real number means 0. Also here negative, positive, all type number here. 0.5 belongs to y number, belongs in the domain, but not having any pre-image in domain. I am taking only simple example. Suppose 0.5, suppose example 0.4, suppose example 0.5, I am taking example. So 0.1, 0.2, 0.3, 0.4, 0.5, any decimal numbers here. So belongs in the codomain. Every decimal number, negative number belongs in the codomain part, but not having the pre-image in the domain. In domain, this is the domain part, this is the codomain part. Here only 1, 2, 3 only positive integers number, yeah, negative integers number having the pre-image in the domain. All positive decimal number, all negative decimal number not having the pre-image in the domain. It means this is a simple example. So then what you can take one more thing, 0 minus 0.4 belongs to y, but not having the pre-image in the, but not same things here, but not having the pre-image in the negative, positive, not having the in this type number, decimal number not having the pre-image in the domain. So this is a simple example here. Yes, note down. So you can say here f is not 1 and onto. Hence f is not onto. So f is not onto. Then you can say f is not onto because this number having the codomain part but not having this unique image in the domain. Yes, note down the very simple things here. Yes, note down the next question. Yes class, next part I am taking question number here, few more questions. Now look at question number 4 to show that the modulus function, both domain and codomain, both are real numbers given by fx equal to, this is symbol of the modulus symbol. Modulus function x is neither 1 nor onto when modulus x is x positive or 0 and modulus x is negative when x is negative. Means modulus function means this is the symbol of the modulus. This is the symbol of the modulus. When you removing this modulus symbol, the value always come in the positive form. Suppose here write here 2, then result will come 2. Suppose here minus write 2, the result always come here 2. Modulus function and greatest integer function both different function. According to symbol, according to values, both way. The modulus function always give the positive value. When removing the modulus, then value come in the positive form. And greatest integer function, the different functions. Then now look here, question number, for solution of this question here. First, function here f, domain and codomain both are real number. Defined by, what defined by here, fx equal greatest integer function x. And this is adding here, x is x, modulus is x when x is positive. It means you convert this function signal function. When it is x, if x is greater than equal to 0, positive or 0. Positive means more 0 and more than x, condition is x. Or when is x, when is the minus x here, if x is less than only 0. In this condition you write here, the modulus is x, value of the modulus is positive x, when x is positive or 0, positive and 0. And when what value of the modulus x, modulus function x is minus x, the modulus value is minus x here when only negative, means less than value of the less than of the 0. So this is the complete questions. Yes, now start the question here. 4 on 2, 4 1 1, 4 1 1. Suppose you are putting a value x equal to minus 1. What value of f minus 1 equal to minus 1? Then value come here 1. Suppose you are putting x equal to 1. Then value is 1 or 1. This is equal to also 1. It means कि f minus 1 equal to f1 equal to 1. Means both the elements having the same image. Negative values and positive, both the elements having the same image here in codomain. So it means so f is not 1 1. So f is not 1 1. Means this function is not 1 1. This function is not 1 1 because minus 1 and plus 1 both having the same image in the domain, codomain. Next 4 on 2, 4 on 2, what function here, fx equal this and y equal modulus function this x. Same things here, when x and y, when x, y belongs is R, this is the given condition. Domain and codomain both having the real number. So domain means x or codomain means y, both having the real numbers. Same things here. Suppose here this is the x and this is the y. But then suppose here writing a negative number minus 1 plus 1 minus 2 plus 2 there here, but here every number here always come here 1 2 3, but minus 1 minus 2 minus 3. In this minus 2 belongs to here, minus 2 belong here, minus 1 also belong here, minus 3 also belong here, minus 4 also belong here, minus 5, all negative number belong here in this y because y is the also real number but not having the pre-image in the domain. देखो minus 1 having the image is 1 or 1 also having the image is 1, but minus 1 not having the image in anyone here. It means कि minus 1 is belong is y, minus 1 is belong in y but not having any pre-image in domain. I am taking only simple one example, minus 1. Suppose you are taking minus 2, then this is also not having the pre-image. This minus 3 also not having any pre-image. Same thing, minus 10, every negative number not having any pre-image in the domain. This is called the image. Domain is called the pre-image. Element of the domain is called the image, or element of the codomain is called the image, or element of the domain is called the pre-image. This is called the pre-image, this is called the image. So every element or every negative element is not having any pre-image in domain. So then this is you have to show f is not onto. Then you can say f is not onto, because positive integer having the pre-image but negative number not having the pre-image here. It means this is not onto, or this is not 1. So yes, this is not equivalence relation, equivalence function. So then not 1, not onto. Yes, note down it. Then next question. Yes, student. Next question I am taking question number 10 question. Question number 10, different type question here. A function here a. Let a equal to set a here. This is not all real number except 3 here. B set here all real number only except 1. Consider the function f8 and a represent here the domain part and b represent here the codomain part. Defined by the function here given is 1 1 and onto. This will be defined to prove that this function is 1 1 and onto. Yes, now start the solution here. Suppose function here given f 8 and to b here defined by fx equal x minus 2 upon x minus 3. Now what is the a, what is the b? A value of the a are given and value of the b are also are given. Means this is the a the domain part and b here codomain part. So now start solution here. 4 1 1 the fx1 equal to fx2 according this way. Okay, this value coming the same or not? So suppose here x1 minus 2 upon x1 minus 3 equal x2 minus 2 upon x2 minus 3. Cross multiply here x1 minus 2 x2 minus 3 equal x2 minus 2 and x1 minus 3. For finding the 1 1 here, fx1 here, this is the condition for polynomial function. Suppose your polynomial function given, this is the using in the only polynomial function. Every function having a different conditions. This is using in the polynomial function fx into fx2. Now multiply here x1 x2 minus 3x1 minus 2x2 minus plus 6. Same here x1 x2 minus 2x minus x1 x2 minus 3 x2 minus 2x1 and minus plus 6. So this is to cancel here x1 x2 3x1 2x1. This will be cancelled here x1 x2 minus 3x1 will cancel here. Sorry, this is not cancelled. 3x2, this is x2, this is x1. 2x2 here write here minus 3x1 2x2 plus this will be cancelled here equal minus 3x2 minus 2x1. x1 here minus 3x1 plus 2x1 minus 3x2 and plus 2x2. Transposing of this minus 2x transposing the right side, or this 2 minus x1 transposing the left side. So what is left here? Minus x1 equal to minus x2. This will be cancelled here. Means x1 equal to x2. What result come here? x1 equal to x2. So f is 1 1. The first result is proved. This result is the proved. F is 1 1. First result has been here proved. F is 1 1. because x1 equal to f2 means x1 and f2 both having the same function, not different function, then means both having the unique image of x1. Second thing, 4 on 2, same that you write here, fx, what value of the fx? Fx equal to x minus 2 upon x minus 3. When you find the onto, then this fx convert in y. Value of the fx is equal to y. X minus 2 upon x minus 3. Cross multiply here. Xy minus 3y equal to x minus 2. Taking x minus xy minus x equal to 3y minus 2. Now look here, this x transposing the left side and this 3y transposing the right side. What is taking here x common? X equal to y minus 1 equal to 3y minus 2. What is value of that? 3y minus 2 upon y minus 1. Value of the x, this is the value of the x. This is the value of the x. And here given to y is not, here given means domain part, r is less than 1. Here given b here, b define here, what is the b define here? Codomain part. Or codomain means all real number except is 1. That means y does not 1. B codomain part, all real number except is 1. Means suppose you are putting here value of the 1, but this is the indefinite value, it come here infinite value means indefinite value, but this is not possible. This is the real number. So this is not real number. This is a real number. Definite value is called the definite value is possible when values are definite, then this is a real number. When value is indefinite, it means this is not real number. So except y does not 1 means r minus 1. What the meaning of this? Means all real number except of the 1. So y does not equal to 1. In this case, first note down it. In this case, x equal 3 minus 2 upon y minus 1 when y does not equal to 1. Except 1. Suppose you are putting the value of the y equal to minus 1. But then what value of the come here? 3 into minus 1 minus 2 upon minus 1 minus 1. Only positive one is not considered here. What result come here? So minus 3 minus 5 upon minus 2. This means 5 by 2. This is the real number. Suppose you are putting any value at y equal to 0. What value of the y here? Minus 2 upon minus 1. This is the 2. This is also belong here. So suppose you are putting any real numbers value here, means this will be having a unique pre-image in the domain. Y you are putting 0 means y is the codomain elements. So what image of this 0 here is plus 2. Suppose you are putting the minus 1 here. So what is image of the minus 1? 5 by 2. It means every elements of the codomain having the pre-image in the domain. So you can say f is 1 1. So f is 1 1, and simple things, you are putting these values in the function fx. Now what value of the fx? Value of the x 3y minus 2 upon y minus 1. And what value of the x? Putting here x minus is 3y minus 2 upon y minus 1 minus 2 upon 3y minus 2 upon y minus 1 minus 3. You are solve this value, then result is coming the y. That means every elements of the codomain having the pre-image in the domain. You can give the simple example, otherwise you solve in this way. Solve any one method. You give the simple example, otherwise solve in this way. means use any one tricks. But then what result come here? 3y minus 2 minus 2y and plus 2 upon 3y minus 2 minus 3y and plus 3. What result come here? 3y and 2y is y, 2 plus this will be cancelled here, and 3y 2y is 3y minus 2y, and 3y 3y are cancelled here, and 3 plus 2 here plus 1. So this result here come y. So this is means so f is onto. So you can say f is onto function. If you, after solving this you are getting the result is y, it means this every elements of the codomain having the pre-image in the domain. It means solve you and give the one example, 2-3 example, otherwise solve this part using any one tricks. Using any one tricks here, result is same, f is onto function. Here 1 1 and the both second year also here proved. Has been proved. First year f is 1 1, second year f is onto. Both result has been here proved that. Yes, note down and then next.